Okay, guys, so I'm going to do this. So we're given this table and this graph. Let f be the function defined by this. Let g be a differentiable function. Now, if they're telling you on a free response that you've got a differentiable function, you need to know right away that that means continuous and smooth. All right, continuous and smooth. So let g be a differentiable function, and we've got this table of values for g and its derivative. The table above gives values of g and its derivative, g prime, at selected values of x. Let h be the function whose graph, consisting of 5 line segments, is shown in the figure above. Okay, so this is h right here. Part A, find the slope of the line tangent to the graph of f at x equals pi. Okay, so slope of the line tangent to the graph, guys, that's the derivative. All right, slope of the line tangent to the graph. So we're asked to find the derivative. So for part A, I'm gonna need to do chain rule twice. All right, on this one, so inside is 2x, outside is cosine of blank. And then on that one, the inside is sine of x, and the outside is e to the blank. All right, so f prime of x. Derivative of the inside for the first one is 2. Derivative of the outside is negative sine of blank, and then 2x goes back in. Plus, the derivative of the inside is cosine of x. Derivative of the outside is e to the blank, and then sine of x goes back in. So f prime of pi, that's going to be negative 2 sine of 2 pi plus cosine of 2 pi e to the sine of pi. Okay, so if you think of the pi circle, which is like this, all right, sine of 2 pi, so 2 pi lands us there. Sine is the y value. The y value there is 0. So that's just 0 plus cosine of, oh, whoopsie, not 2 pi, that's just pi, my bad. All right, so cosine of pi, pi is there. Cosine is the x value, so that's negative 1 times e to the sine of pi. All right, so pi brings us to that point, and the y coordinate is 0. All right, so this just ends up being negative 1. All right, because e to the 0 is positive 1. So that is part A. Now part B. Part B. Let k be the function defined by this. Find k prime of x. And now, guys, if you look here, this is another chain rule situation. The inside this time is f of x, and the outside is h of blank. Okay, so k prime of x, the derivative of the inside is f prime of x, derivative of the outside is h prime of blank, and then f of x goes back in. But we want k prime of pi. So I need f prime of pi times h prime of f of pi. Okay. Now, guys, f prime of pi, we already found that. That was negative 1. All right, so we already found that in part A, that was negative 1. Now, f of pi. All right, so f of pi equals, all right, and f is the function that they gave us. So this is cosine of 2 pi plus e to the sine of pi. Cosine of 2 pi is 1 plus e to the sine of pi is e to the 0, so that's 2. Yeah. All right. then, so this is times h prime of 2. Now, h prime of 2, we need to use this graph. All right, so we need the slope of the tangent line to the graph at that point. Guys, they already told you this graph consists of lines. So this is a situation where the slope of the tangent line is the same as the slope of that line. So so the slope there is, so the rise, so down 1, right 3. So negative 1/3. So that's h prime of 2. So h prime of 2. So this is negative 1 times negative 1/3, 1/3. Okay, that's the answer for the second part. Okay, now for C. All right, so here is C. Let m be the function defined by this. Find m prime of 2. All right, so this is part C. So, all right, so this is also a chain rule situation. So maybe like right here, I'll just say like off to the side, in, out. So negative 2x and then g of blank. All right, so m prime of x, I need to do the product rule and its chain rule inside. So for the derivative of this one, the derivative of the inside is negative 2, derivative of outside is g prime of blank, and negative 2x goes back in. Bring down the h of x, plus bring down the g of negative 2x. And then the derivative of h of x is h prime of x. And now we want to plug 2 in. G prime of negative 4, h of 2, plus g of negative 4, h prime of 2, equals negative 2. G prime of 4, that is from the table, so that's 5. No, it's negative 1. Now, h of 2. Guys, for h of 2, we look at this picture here. H of 2 is that y value. Okay, h of 2 is that y value. So you know what? There's actually a couple of ways to find this y value for that point. You could use similar triangles actually, or a ratio, because like negative 1 to 3 is the same as, wait. So negative 1 to 3 is the same as that y value, the y value to 2. So you could like set up a ratio like that, or guys, the equation of this line, what is the equation of this line? The equation of that line is y equals negative 1/3 x. All right, so that's another way that you could figure it out. All right, and always, like, if there's anything that you're unsure about, you could comment in the survey, like, how did you know, how did you know for this free response question number 8, how did you know that the equation of this line was that, or something like that. Okay, so h of 2, I just have to plug, so for this part here, so for that y value, I just plug 2 in for that x value. So that's negative 2/3 plus g of negative 4 is 5. And then h prime of 2 is negative 1/3. I already found that. Yeah, I had to find that to get that part, because when I did m prime of 2. Oh, wait, no, I'm doing that now. Oh, for this part here, we had to do h prime of -2 for that part there. No, of +2. I had to do h prime of 2 there. Yeah, so I already used that. Okay, so this is -4/3 minus 5/3, -9/3, that's -3. Okay, so that is part C. And then part D. For part D. Is there a number C in the closed interval -5 to -3 such that g prime of C equals -4? Guys, this is a case for the mean value theorem. If it was g of C equals -4, that would be the intermediate value theorem. But when they're asking you to show that the derivative takes on a certain value on a certain interval, that's the mean value theorem. Okay, so from -5 to -3, we want to look at this. All right, so from -5, so I'm looking at like this part of the table right there. Okay, so I want, all right, so I guess you have to decide, like, can we just use the mean value theorem on this interval, or would we need to use it on a subinterval? Like a subinterval would be maybe like -5 to -4 or -4 to -3. Those would be the subintervals, but hopefully I'm going to get the average rate of change from here to here to be 4. All right, so let me see. So g of -3 minus g of -5 all over -3 minus -5. All right, so right now I'm finding the average rate of change on that interval. This ends up being 2 minus 10 all over 2. This is -8 over 2. That is -4, which is what they want me to prove that the derivative equals at some point. And we've got it, guys. The conclusion of the mean value theorem says, well, okay, now we have to like go into it. All right, so for the mean value theorem, I need to say that the function g is continuous on the closed interval from -3, or from -5 to -3. And then I need to say that it's differentiable on the open interval. And at the beginning here, guys, they said let g be a differentiable function. That means continuous and smooth. So I can say right here, since g, or I'll be like, since we are told g is differentiable, g is continuous on what am I doing? On -5 to -3 and differentiable on -5 to -3. Therefore, by the mean value theorem, there is a C where C is, you know, strictly between -5 and -3, not less than or equals to, just less thans, for which f prime of C equals -4. And guys, I am good to jump right to this because I showed this work up above, excuse me, that shows that my average rate of change over this interval is -4. Boom. Guys, you can do that. Absolutely.